Let's solve some past exam questions. The first question, how many complete waves are indicated in the sketch? So let's go ahead and find out. We have our sketch right here. There we go. We have our line of equilibrium. Now let's start counting. Let's see how many complete waves are indicated in the sketch. One wave, one complete wave is one cycle. So let's go ahead and start counting. So from this point right here, if we keep going, we have one full cycle when we reach this point. Here we have one full cycle. That is one wave. Let's keep going. Why are we saying it's one wave? Maybe we can touch on that first. If you take a look, this is half a cycle and this is another half. If you add those two, you get one complete cycle, one complete wave. So that's why we're saying we have one wave. And then if we keep going, at this point right here, we have our second wave. Again, half a cycle, one complete wave. And now let's go ahead and continue counting. If we keep going, when we reach this point, we have the third wave. Half a cycle, half a cycle. Half and half will always give you one whole. So there we go. We have three waves. How many complete waves are indicated on the sketch? 3 complete waves. The second question, write down the letters that indicate any 2 points that are in phase. We're interested in points that are in phase. Maybe what we want to do first is to just define what it means when 2 points are in phase. Points are in phase when they have a whole number of wavelength in between them. So if between any 2 points there is one wavelength, they're in phase. 2 wavelength, they're in phase. 3 wavelength, they're in phase. As long as it's a whole number of wavelength in between the 2 points, then they are in phase. For instance, B and D. B and D are 2 points that are in phase. The same is true with C and E. There's one wavelength between C and E. So those are other 2 points that are in phase. But kid you not, between C and G, we have 2 points that are in phase because there is 1, 2 wavelength in between them. So B and D is an answer, C and G is an answer, D and F is an answer, also B and F, because from B to F we have 2 complete waves. So that's a whole number of wavelengths. So there we go. Those are points that are in phase. And then there's no in between. If 2 points are not in phase, they are out of phase. So points C and F are not in phase. They're out of phase. Point A and B, they're also out of phase because there is no whole number of wavelength in between them. For 2.2, we can just say A and C. A and C are 2 points that are out of phase. And then 2.3, we're supposed to indicate any 2 points that represent one wavelength. So don't get this question wrong. Any 2 successive crests will represent one wavelength. So B and D, from B to D, we have one wavelength. From D to F, we have another wavelength. And then from C to E, we have another wavelength. And the same is true with E and G. That's another wavelength. So the answer to 2.3, we can just say B and D. Between B and D, we have another wavelength. Let's go ahead and do question 3. Calculate the amplitude of the wave. From the given information, the height of the wave from the trough to the crest is 1.5 meters, and the amplitude should be half that. We know that the amplitude is the height from the rest position to the crest, or from the rest position to the trough. not from the trough to the crest. So in this case, we can say that the amplitude is equals to 1.5 divided by 2, which will be equals to 0.75 meters. So there we go. We have our amplitude, which is 0.75 meters. It's very rare that in an exam situation, you will be given the amplitude in a straightforward manner. The amplitude is 1 meters. It's very rare that you're given a situation like that. Usually, you have to calculate it. There's a bit of trickery that you have to overcome in order to find your amplitude. And then the fourth question, calculate the period of the wave. So let's go ahead and take a look at the given information. 8 waves hit the seawall in 5 seconds. So we have 8 waves hitting the seawall in 5 seconds. That is actually all the information we need to calculate the period, because we don't have the frequency in this situation. So we cannot use frequency to calculate the period. But we can say that the period T is equals to the change in time divided by the number of waves. If we use this formula, we're going to get the period. Why does this formula hold? Why is it true? The period is the amount of time taken to complete one wave. If we divide the total time by the total number of waves, we're going to find how much time it takes to complete one wave. So delta T will be equals to, the time is 5 seconds and the number of waves is 8. And I'm getting 0.625 seconds. So there we go. We have the period of the wave. Let's move to the question that follows. Question 5, calculate the frequency of the waves. If we already have the period, calculating the frequency becomes extremely easy. So the frequency will be equals to 1 divided by the period. This is 1 divided by the period, which is 0.625. So what is 1 divided by 0.625? 1.6. So we have the frequency being equals to 1.6 hertz. And there we go. We have the frequency. If you have the period, it's really easy to calculate the frequency, and vice versa. The last question, calculate the velocity of the waves. So we have the frequency, we have the period, but I don't think we can use the period to calculate the velocity. What else do we have? We have the wavelength. It's given to us in the diagram provided. Now we're looking for the velocity. Should be easy to see that the velocity will be equal to the frequency multiplied by the wavelength. The frequency is 1.6 hertz, and then the wavelength is right here. From C to E, we have one wavelength, and that is 9 meters. So 1.6 multiplied by 9 meters, that is 14.4 meters per second. And just like that, we have our velocity.